Hi everyone, I'm Stephen Taskin and welcome to one of my presentations on Revit Conceptual Massing Design Environment. This exercise was part of my presentation at the Revit Technology Conference held in Los Angeles this year. This example is a basic use of textile weaving system produced by the horizontal tessellation. The component we're about to create is interlocking or interlacing by sliding and looping to form larger surface. So let's get started. We now open a new curtain panel pattern-based family, and before we go any further, I would like to show you the intent of what we're trying to do. We are trying to create a line between two circles that it's always tangent to those circles regardless of their sizes. So that's basically the a geometry solution that we're looking at, and just earlier on I've just calculated the angle value of the tangent point of the line to the circle. So having that in mind, we'll just go back to our Revit family. I'll just pick the pattern and change the default rectangle pattern to 1.5 step pattern, and now what we're going to do, we're going to select two adaptive points within the pattern family and just dimension between two. We'll just turn that dimension into a reporting dimension of a length, so we'll call it L, and to have a reporting parameter, obviously it needs to be instance parameter. Tick reporting parameter option, and because I'm going to use this in the formulas later on, I would like to place all my formula values, parameters under data, group them under data, or it can be grouped under others, but somewhere that it's actually different than the dimensions or constraints of the constructions of these elements. So there you are. We now have a reporting parameter between these 2 points that will tell us is the size will flex the length of these points on the left hand side, given the condition that these patterns will be symmetrical on the right hand side. So by default we will be controlling the point on the right hand side through this reporting parameter as well. So now, going back to these 2 points, we are going to place the circles as a reference lines, as you've seen in the earlier image, and now we'll just set the reference plane of that point, create our circle, just any dimension. It's not really, I haven't worked out any particular dimensions for this thing, so we'll just turn the radius into a parametric value. I'll just call it R for radius for the time being. It's not really critical whether it's a type or instance, but I'll just keep going with instances. Generally that's my practice of creating these elements. So I'll be repeating the same process just by selecting the reference plane of this point and creating a circle, again assigning a parametric value. We'll just call it R1 instance under dimensions and the value there. So we've got our basic 2 circles, and I'll just go back to the family types and add a parameter called thickness, because that would be the difference between these 2 circles. As we put a material in between, the thickness of that material would be the difference between 2 radiuses. So I'll just assign that. It's not critical at the moment. I'll just call it 300 mil. And what I'm going to do with that thickness, I'm going to say that second circle is really the first circle plus the thickness itself. So if we just apply that, and now as you can see we have that circle. I'll just enlarge the horizontal spacing of this form, and doing everything in metric at the moment, so I'll just turn that to a metric value as well. And now we have our basic circles in place. Now the next thing I'll be doing, placing a point on one of these circles, and then selecting this point, turning the measurement type of this point to be an angle measurement, and I'm going to assign a parameter for this as well, which we'll call it angle. And again, instance, we'll leave it down the dimensions, so we've got an angle point. Now we need to assign the formula for that point, that we know that the when we draw the line, that tangent point will always be perpendicular to the circle itself. So as you've seen in the image earlier on, so I'll just flash that image back in again. So basically that's the angle of the point that we're after, and we've got quite a complex formula to drive that the point. And what I'm going to do, I'm going to break that into two parts. So I'm going to use the top part, and I'm going to call that as a function, so it's a bit easier to type it in there. So let's create a parameter called function, and I'll make that instance. And as we talked about before, we'll put this under data, and now we've got a function. Again, just to be quick in these exercises, I'll just give myself a little notepad with these formulas is already on, so I'll just copy and paste that formula, just apply. So we've got that one part of the formula, as we named it, function, working. Now for the angle itself, we'll continue to put the formula that this function will be part of. So if I can copy, paste this into the right field, apply. Now we know our angle point being 19.47 degrees at the moment is the point that will make that line always tangent to that circle. So once again, the reason I've done two parts, I've just simplified the amount of formula that I'm going to write in one column. So I just broke it into two, which you may want to do it in one go. So let's accept that. So that now we know that point is exactly where we want it to be. So similarly, I'll place the second point to the second circle, select the point, turn that into the measurement type of an angle, and then we'll call this one as an angle opposite. And it's an instance like the rest, so we'll just put it under dimensions. So we've got an angle opposite. If we go back to the family types, then we can say angle opposite will always be 180 degrees plus the angle itself. So if we apply that, so now we have 2 points that we know once we join these with a reference line, which will turn the 3D snapping on. That's quite critical for it to flex properly within the massing environment. So we've got now a reference line is joining those 2 points, and that's pretty much what we were trying to achieve, as you've seen it in that early image. And now, matter of repeating that exercise for the other points, I'm just going to pause that for a moment so we can do the repetitive work. Now, as you can see, we have repeated the same exercise, which we've placed all our circles, the parametric radiuses, the points, and these points are joined with the reference lines. Now, just to continue our framework, we'll join rest of the points to create our first reference square for the material. Okay, now the second step